In today's lecture, we'll study about inverse trigonometric functions, which is given in chapter 2 of mathematics for class 12. As you all know, the syllabus for the academic year 2021 has been reduced. The written portions are introduction, basic concepts, and principal values, whereas graphs of inverse trigonometric functions and elementary properties of inverse trigonometric function has been deleted. The total marks for this chapter are 8 in your board examination. These marks are divided as 1 mark question 1, 2 marks questions 2 numbers, and 3 marks question 1 number. This is a very easy chapter, but you have to remember many formulae and derivations which you have studied in your class 10 and class 11. And the difficult portions like graph of inverse trigonometric function and elementary properties have been deleted. Let us start. Inverse trigonometric function. Let us define. Inverse trigonometric functions or cyclometric functions are the inverse functions of trigonometric functions when their domains are restricted. Please note, the inverse functions, the domains are restricted to principal value branch to make it trigonometric functions bijective. Bijective means the domain and the region should satisfy 1 as well as onto conditions. So all inverse trigonometric functions are bijective. If any function is not bijective, then it is not inverse trigonometric function. This is very important. So in order to make the trigonometric bijective, domains are restricted. That means the boundaries are given to the principal values. That is for the region. So all inverse trigonometric functions are bijective. If it is not bijective, then it is not an inverse trigonometric function. Please note it, it is very important. The inverse function f, if f is 1 to 1 and on to, the inverse function f is denoted by f to the power of minus 1. That is f inverse. If f from x to y, then f inverse will be y to x. That is, if the conditions are satisfied from x to y, this x is a domain and y is a region. If it satisfies 1 to 1 1 and onto function and x is related to y, then inverse f inverse will be y to x. It is also represented as f inverse of equals 1 suffix x and f of f to the power of minus 1 is equal to 1 suffix y. Please note a very important point. Sine inverse y, this is sine inverse, this is read as sine inverse y, does not mean within bracket sine y to the power of minus 1. This relation sine y, function sine y to the power of minus 1 equals to 1 over sine y. But 1 over sine y is not equal to sine inverse of y. Sine y is a notation. Sine to the power minus 1 is a notation. whereas sin y whole to the power of minus 1 is a relation 1 over sin y. Now, having defined inverse trigonometric function, let us list some of the relations between domain and the region associated with inverse trigonometric function. Having studied that, we have seen that all trigonometric inverse function should be bijection, should meet the condition of bijection. That is, it should satisfy the domain and the range should satisfy 1, 1 and onto conditions which we have studied in the chapter number 1. The domains in this table displayed before you, the inverse trigonometric functions are given in column number 1 under the heading name. If we take the first one, arc sine, that is arc sine, it is noted as y is equal to sine inverse of x. Here there are two groups. The domain, that first set is called domain and it is given as x. And the second set is denoted by y. So there is a relationship between x and y. The domain of x has also certain boundaries for each of the inverse trigonometric function. Suppose take the first row here in the table, arc sine, it is noted as y is equal to sine inverse of x. And it is defined the x, that is the domain is x is equal to sine y. That is the first set is x and it is sine y, sine of the x. And its boundaries and domain is specified. It is between minus 1 less than or equal to x less than or equal to 1. Therefore, y, that is the range in group y, that is the second set, has limitations or boundaries of minus pi by 2 less than or equal to y less than or equal to pi by 2 in this set, that is range. This is expressed pi by minus pi by 2 and plus pi by 2 is expressed in radians. In terms of degrees, if you want to specify, it has to be stated as minus 90 degrees less than or equal to y less than or equal to 90 degrees. This is in degrees. The last column is in degrees. So range y is given. Sometimes it is also called the principal range. Okay, principal. So this is a set A having x sine ratios. It is, suppose you say a group A set X, it will have the ratios minus 1, minus half, minus 2, like that, 1 by 2, 1 by 2, and maximum is 1. So we have fixed the boundaries in the x-axis. X-axis is between minus 1 and plus 1 for sine inverse function. For sine inverse function, the x boundaries varies between minus 1 and plus 1. Similarly, when we say x is equal to sine of y, the y boundaries, that is y is equal to sine inverse of x, the boundaries or the range in radians is minus pi by 2 less than or equal to y less than or equal to pi by 2. This is in the vertical axis, that is y axis. Y axis, the domain or the range of sine is minus, that is negative, minus to positive 90, that is minus 90 degrees by plus 90 degrees. All this explanation was given for y is equal to sine inverse x or x is equal to sine y. Both should satisfy the conditions 1, 1 and on 2. That is, they should be bijection. The relationship for the other trigonometric functions, that is arc cosine, y is equal to cos inverse of x and x is equal to cos y. That is inverse of that. Y is equal to cos inverse of x or x is equal to cos y. This is reverse of that. And this range also is given. The range for cos is 0 degrees to 180 degrees. That is 0 to 180. So it is 0 to pi also. For tangent, it is y is equal to tan inverse of x or x is equal to tan inverse of y. But you know, tangent, the boundaries or the domain is all real numbers. Because we know opposite side by adjacent side, if the denominator becomes 0, it goes to infinity. So we have to fix its boundaries. The boundary for tan y is minus pi by 2 to plus pi by 2 or minus 90 by plus 90. Similarly, for cotangent, y is equal to cot inverse of x and x is equal to cot y at all real numbers, and its range is between 0 to pi, 0 to 180 degrees. Arc secant is also given here. Y is equal to secant inverse of x and x is equal to secant y, and its range is minus 1. That is, x should be minus 1 or x should be less than minus 1 or x should be greater than 1. And its range is, the degree range is 0 to 180 degrees or 90. So 0 is excluded here. You please note here for secant there is no 0. It should be minus. X should be less than or equal to minus 1 or x should be greater than x. So there is no 0. So arc cosecant also, y is equal to cosecant inverse x or x is equal to cosecant y or x is equal to, x should be less than or equal to minus 1 or y is, or 1 should be less than or equal to x. Therefore, this is minus pi by 2 to 0 or 0 to pi less than or equal to pi by 2. These ranges are given. Please note down very clear. In this slide, we will recollect the relationship between inverse trigonometric functions, that is, principal value branches with domain and ranges. Please see the table shown on the screen. On the left hand side, we have inverse trigonometric function. And the next column is domain and ranges. Let us take for example sine inverse of x. The function or the domain, the domain lies between minus 1 and 1. For these values of minus 1 and 1, which is again mapped on to the ranges, that is y minus pi by 2 comma pi by 2. For all values lying between -1 and 1, the inverse of sine inverse x, that is sine inverse x, lies between the range is -pi/2 comma pi/2. Only for these two conditions, that is group X, set A, the values, set A, and this is set B. The values of set B, always the sine inverse of X is theta, that is angle. Always remember, the sine inverse value is always in terms of the answer for sine inverse is theta. Hence, on the right hand side, the range is -pi/2 comma pi/2. For other angles, cos inverse of x, the domain is -1 and 1. When it is mapped onto -1 to 0 and 0 comma pi/2. For tan inverse of function, the domain is all real values, all real numbers, and the y range or inverse tan inverse of x is between -pi/2 comma pi/2. The next is cot inverse x. For cot inverse x, the domain is all real values R, that is x, where is x value is all real numbers R, and it is mapped onto group B. Our range is 0 to pi, 0 comma pi. For secant inverse of x, the domain is R minus within small bracket -1 comma 1, and the range is 0 comma pi minus of pi/2. So the range is 0 comma pi subtracting except pi/2. And for cosecant inverse x, the domain is all real numbers R minus of the region -1 comma 1 to -pi/2 comma pi/2 minus of 0. Please remember all these and practice. In the next slide, we will show the graph. Graph is not included in your syllabus, but still to understand the domain and ranges and their function, inverse trigonometric function, it is very essential. It is shown on the right hand side. Please see here, sine inverse x is -1 comma 1. Hence, you see, this is -1 is here, x value -1 and plus value is here. Therefore, it lies between here, the top point is the plus pi/2 and the bottom, the negative is minus pi/2. This is for sine inverse x. For cos inverse x, the graph 2 is given here. Its value, x lies between -1. You see, x is -1 here and +1 here. And the angle, sine inverse value is 0 to plus pi/2. It is here. You see, it is pi/2. This is the graph for cos inverse x. For tan inverse x, the range is all real values 0 to infinity and 0 to minus infinity, because this graph is not meeting here at the, and here the top point here is y is equal to pi/2 and the bottom dotted line is minus pi/2. So the range is minus pi/2 to plus pi/2, and here it meets at infinity. That is all real values. Tan inverse satisfies range is R. Domain is R and range is minus pi by 2 to pi by 2. This is the range between these two dotted lines. For cot inverse, the range is R, all values of R minus of R, and range is 0 to, see, it starts from 0 to pi. This is the pi. So it is 0 to pi. And for 0, it is here in between, it is 0 to pi by 2. Cot inverse. For secant inverse, the graph fifth is applicable. Here R minus of minus 1, 1. So minus 1 is here and plus 1 is here. So there is no graph falling between minus 1 to 1. Therefore, R for all values starting from minus 1 onwards as well as plus 1 onwards. The graph is like this. And on the y coordinate, pi is on the top. So it is 0 to pi. The range is 0 to pi. Range is on y. Minus of pi by 2. So minus pi by 2, here it is pi by 2, it is not defined. This is dotted line is pi by 2. The last one is sixth, graph of y. Therefore, graph of y, cosecant y is given by r minus, the domain is r minus of minus 1 comma 1. Therefore, this is r minus 1 is this side and plus 1. Hence, the graph is not given in this region. Whereas for other values of r, that is r minus of minus 1, 1, the graph is like this. So it is minus 1 and minus pi by 2. Here it is pi by 2. And this is again, here it is pi by 2. So pi by 2, it starts for all values minus of 0. Hence, please remember and practice this. The inverse trigonometric function, we will revise properties of inverse trigonometric function. Though the portion has been deleted, this is very important for solving all the problems of inverse trigonometric function. Let us take one. Sine inverse of sine theta is equal to theta. That is, sine inverse of sine theta equals theta. Cos inverse of cos theta is equal to theta. Tan inverse of tan theta is equal to theta. That is inverse and the other main x. Suppose tan theta is x and tan inverse is y. So tan inverse of tan theta will be equal to theta. Similarly, cosec inverse will be equal to cosec theta. Cosec inverse of cosec theta is equal to theta. Secant inverse of secant theta is theta. And cot inverse of cot theta is equal to theta. The next properties are, that is, cosecant inverse x is equal to sine inverse 1 by x. Please note very carefully. Cosecant inverse x is equal to sine inverse of 1 by x. Secant inverse of x is equal to cos inverse of 1 by x. And cot inverse of x is equal to tan inverse of 1 by x. And the boundaries are also given, where mod x is greater than or equal to 1 for cosecant x. Mod x is greater than or equal to 1. And secant x has a boundaries where mod x is greater than or equal to 1. And cot inverse is greater than, x is greater than 0. X is not 0. Please note that x is not 0 but greater than 0. Further, we'll continue with the properties. Is and the next property is in group B we have given sine inverse of x plus cos inverse of x is equal to pi by 2, and the boundaries, and here x belongs to -1 and 1. Here the boundary is x, the value of x, the boundaries are fixed as -1 and 1. Similarly, for tan inverse and cot inverse x, tan inverse of x and cot inverse of x equal to pi by 2, where x belongs to the real numbers, or x belongs to R, a real number. Third relation is secant inverse of x plus cosecant inverse of x is equal to pi by x, where mod x is greater than or equal to 1. The third group is sine inverse of minus x is equal to minus of sine inverse x. X belongs to, the boundaries of x are -1 and 1. Tan inverse of minus x is equal to minus tan inverse x, but here x belongs to R. It is not -1 or 1. It is from infinity to minus infinity, which is represented as x belongs to R. This is very important so far as tan inverse function is concerned. Cosecant inverse of minus x is equal to minus cosecant inverse x, where x mod x belongs to greater than or 1. This we have seen in previous example also, previous grouping also. Therefore, the cos inverse of minus x is, please note here, cos inverse of minus x is pi minus cos inverse of x. X belonging to -1 and 1. So, cos inverse of x is pi minus cos inverse x, whereas sine inverse of minus x is minus of sine x. Secant of minus x is equal to pi minus secant inverse x. The mod x is greater than or equal to 1. And cot inverse of minus x equals pi minus cot inverse of x, where x belongs to R. So these relationship you note down. So for cos, secant and cot, it is, the relation is pi minus cos inverse x. And the boundaries also you have to note down. You have to remember all this. You note down and write repeatedly. When you practice it, you will be able to remember very easily. The next group of formulae is formulae for addition and subtraction with ranges. This is displayed or indicated in the table. Number 3 is for formulae for addition, subtraction and inverse trigonometric function. Tan inverse, the most important is tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. Similarly, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y divided by 1 plus xy. Similarly, tan inverse of x plus tan inverse of y plus tan inverse of z equals tan inverse of x plus y plus z minus xyz divided by 1 minus xy minus yz and minus zx. Similarly, the relations for cos inverse and cos inverse of x and cos inverse y have also been given. Please note down and practice it and try to remember it. The corresponding boundaries are also given in the last column, that is third column, where x is greater than 0, y greater than 0 and xy is less than 1 for relation between for tan inverse x plus tan inverse of y is equal to tan inverse of x plus y divided by x minus y. Conversion of trigonometric function into another function is also important for solving problems associated with inverse trigonometric function. These relationships are also given in the table number 4. Here 2 tan inverse x is equal to sine inverse of 2x by 1x square, 1 plus x square, that is equal to cos inverse of 1 minus x square divided by 1 plus x square, that is equal to tan inverse of 2x over 1 minus x square. Please note here, derivations are not have been deleted from the portions for this year, but formulae you have to remember. Please note down all the formulae, all the 4 formulae for conversion of trigonometric function into another. This is very important for solving the problems. So having studied the basic formulae and relationship and properties, we will take up 1 mark question. For question number 1, find principal value of sine inverse of 1 by root 2. Let us put sine inverse of the given function as y, which is between, for sine function, minus pi by 2 to plus pi by 2. That y lies between minus pi by 2 to plus pi by 2. Therefore, if you take the sine y becomes 1 over root 2. So the sine inverse has gone and it has become the trigonometric ratio. Therefore, sine y is equal to, we know the value 1 over root 2 from our trigonometric function, y is equal to sine of pi by 4 is equal to 1 by root 2. Therefore, sine y is equal to sine pi by 4. Therefore, y is equal to pi by 4. Therefore, the principal value of sine inverse 1 by root 2 equals pi by 4. This is the answer. The principal value or the range. Question number 2. Find the principal value of cosecant inverse minus root 2. Therefore, cosecant inverse is equal to, within brackets, minus root 2. That is equal to y. Put y is equal to cosecant inverse of, within brackets, minus root 2. Then y will be equal to, if you take, y will be equal to minus, then sine y will be is equal to minus root 2, where y belongs to minus pi by 2 to pi by 2. Therefore, cosecant y is negative. You see, y value is negative. And y is also negative. Here you see y is also negative. And lies in the domain minus theta. So you see, it is cosecant inverse minus theta. Therefore, cosecant inverse of minus root 2, here the same, is equal to minus of cosecant root 2. This is the basic relation. Cosecant inverse of minus theta is minus of cosecant theta. This is the relationship given. You see here, cosecant, because cosecant of minus theta is equal to minus of cosecant theta in this condition. Therefore, minus of cosecant inverse, cosecant of root 2 is minus pi by 4. Therefore, cosecant inverse and cosecant neutralize, and therefore it is minus of pi by 4. That is the value. So therefore, cosecant inverse of minus root 2 is minus pi by 4. Therefore, principal value of cosecant square minus 1 is minus root 2 is minus pi by 4. Next question. Find the principal value of function sine inverse sine 2 pi by 3. The answer, the solution. We have sine inverse is equal to sine x or x. See, this is sine inverse of sine x, where x is 2 pi by 3. Therefore, we have to put this value as x. Therefore, sine inverse of sine 2 pi by 3 equals 2 pi by 3. That is sine inverse and sine inverse get cancelled, and this value we get. Sine inverse of sine theta is theta, we know. So using that relation we get answer as 2 pi by 3. But in this equation, in this solution answer, 2 pi by 3 does not belong to minus pi by 2 or pi by 2, which is a principal value branch of sine inverse. We know sine inverse should fall between the range is minus 90 to plus 90. But 2 pi by 3 is not falling into that. Therefore, sine inverse of sine 3, we have to put it as 2 pi minus 2 pi is equal to 3 pi minus pi divided by 3. Therefore, sine inverse of sine, this is pi 3 pi by 3 is pi minus pi by 3. So we have converted into 180 degrees the angle relations. Therefore, sine inverse of, we know sine of 180 minus theta is 1 minus is sine theta. Sine pi minus pi by 3 is sine pi by 3. Therefore, sine inverse of sine becomes pi by 3. Therefore, sine inverse of sine 2 pi by 3 is equal to pi by 3. This is the answer. Find the value of cos inverse of, within big bracket, cos of 13 pi by 6. This is we have to find. These are all 1 mark question. Very simple. Cos inverse of cos into 13. Just it is a given function. Therefore, here x is equal to, this x is equal to, this is the term in the big bracket is cos of 13 pi by 6. So that becomes 13 pi can be written as 12 pi plus pi divided by 6. So we are expressing it in terms of radians, that is 180 degrees, relations 180 degrees. Therefore, that is cos inverse, as it is cos inverse, into cos of 12 pi by 6 is 2 pi, plus this pi divided by 6 remains as it is. Therefore, the given relation, this relation becomes cos inverse of cos of pi by 6. That is 2 pi is 180. 360. This is 360 plus theta. So cos of 360 plus theta is cos theta itself. Therefore, the answer is this becomes cos inverse and cos, and the relation is pi by 6. Pi by 6 is root 3 by cos A. This is cos inverse of root 3 by 2. Therefore, the answer is pi by 6. As it is, this is not needed. You can put cos inverse of cos as pi by 6. That is the answer. Let us take example number 5. Show that sine inverse of 2x into square root of 1 minus x square is equal to 2 sine inverse x, comma, where x lies between minus half less than or equal to x less than or equal to plus, the range is minus of 1 by root 2 less than or equal to x less than or equal to 1 by root 2. Solution. Let sine inverse x is equal to theta. That is, the item in the bracket be theta. The sine inverse, first step is put sine inverse x is equal to theta or any other value. So that therefore x will be is sine, x equals sine theta. That is reverse of, inverse of this. X is equal to sine theta. Therefore, we have sine inverse of 2 sine theta, that is 2x is given, 2 sine theta into 1 minus sine square theta, that is substituting the value of x in the equation, in the given equation on the left hand side of the equation. Therefore, that is equal to sine inverse of 2 sine theta cos theta, that is 2 sine theta as it is. We know sine square theta plus cos square theta is equal to 1. Therefore, cos square theta is equal to 1 minus sine square theta, or cos theta is square root of 1 minus sine square theta. That we have just substituted the value of under root 1 minus sine square theta in this equation. Therefore, that is equal to sine inverse of sine 2 theta. That is, using the relationship sine 2 theta is equal to 2 sine theta cos theta. So here this relationship we have to recollect from what we have studied in 10th standard and 11th standard. That is sine 2 theta is equal to 2 sine theta cos theta. Therefore, sine inverse of sine 2 theta, sine inverse and sine get cancelled. That is, sine inverse of sine is 2 theta. Therefore, the answer is 2 theta for this partial solution. Therefore, that is equal to, we know, so 2 theta is sine inverse of x here from here. Therefore, 2 into sine inverse of x. That is, we have proved it. That is, its answer is 2 sine inverse x. Yeah. Next problem, number 6. Evaluate sine inverse of sine of minus 600. Therefore, sine inverse of minus 600. So, this minus 6, we can take it out, because sine of minus k is minus k sine. Therefore, sine inverse of minus sine 600. Therefore, sine inverse of this 600 can be written as 360 plus 240. Therefore, using the trigonometric relations, this can be written, 240 can be written as 180 plus 60. This 360 is a one complete circle, so it can be neglected, and this can be written as 240 equals 180 plus 60. So for that is equal to sine inverse of this relationship of 180 degrees. 180 plus, we know sine pi plus 60 is sine pi. Therefore, that is equal to sine inverse of sine 60. Therefore, answer is sine inverse of sine of minus 600 degrees is 60 degrees. Problem number 7. Find the values of cos inverse of half plus 2 sine inverse of half. Therefore, cos inverse, answer, cos inverse of 1 by 2 plus 2 sine inverse of 1 by 2 is given, and we know cos half is pi by 3. Therefore, cos inverse of half is pi by 3 plus 2 into sine inverse of half is pi by 6. That is equal to adding this 2 get cancelled, pi by 3 plus pi by 3. That is 2 pi by 3 is the answer. Next question. Find the value of cot of, within brackets, tan inverse A plus cot inverse A. These are all 1 mark question and very simple solutions. Therefore, we know that the relationship tan inverse x plus cot inverse x is equal to pi by 2 for all values lying for x belonging to R. R, that is the real number. Both tan and cot inverse lie for all values, real values. Hence, cot of tan inverse A plus cot inverse A equals This is equal to cot pi by 2. That is here tan inverse A plus cot inverse A is equal to pi by 2. This becomes completely pi by 2. Hence that is equal to cot pi by 2. That is equal to 0. That is the answer. Two marks questions with answers. Question number 1. Prove that sine inverse of x plus cos inverse of x equal to pi by 2, x belonging to within closed boundary -1 to 1. Solution. Let sine inverse be equal to theta. That is, put sine inverse x is equal to theta. Therefore, x will be equal to sine theta. That is between, for this theta, minus pi by 2 to theta less than or equal to pi by 2. Therefore, sin theta, we can write sin theta as sin theta is equal to cos of pi by 2 minus theta, that is 90 minus theta, from our knowledge of class 10 trigonometry. Therefore, becomes cos of pi by 2 minus theta equal to x. Therefore, if we take a cos inverse of cos pi minus theta, or pi by 2 minus theta is equal to cos inverse x. Therefore, pi by 2 is equal to retain cos inverse of x as it is and move this minus theta to the right hand side. Therefore, pi by 2 is equal to cos inverse x plus theta. Therefore, pi by 2 as it is, cos inverse of x as it is, and substitute the value of theta. Theta equal to sin inverse x. Therefore, sin inverse x plus right hand side is sin inverse x plus cos inverse x. Therefore, pi by 2 is equal to sin inverse x plus cos inverse x. So, this is, we have proved it as required in the question. Therefore, pi by 2 equals sin inverse of x plus cos inverse of x. Question number 2. Prove that tan inverse of x is equal to half of cos inverse of within brackets 1 minus x divided by 1 plus x, where x is belonging to 0 and 1. The range of x is 0 and 1. Let tan inverse x is equal to theta. So, therefore, x is equal to tan theta. So, here that is x is equal to tan theta. Or squaring, we get x square is equal to tan square theta. Therefore, right hand side is given is here, right hand side of the problem is half of cos inverse of 1 minus x over 1 plus x square. Therefore, x is, we have put tan theta, or x square is equal to half of cos inverse of 1 minus tan square theta plus 1 divided by tan square theta. Therefore, this relationship 1 minus tan squared theta divided by 1 square tan squared theta can be written of cos 2 theta. That is from the knowledge of our trigonometry. Therefore, half of 2 theta will be equal to theta, that is equal to tan inverse of root x, that is left hand side. Next problem. Prove that 3 cos inverse of x equals cos inverse of 4x cube minus 3x for all values of x belonging to half and 1. Let cos inverse of x equals theta. That is cos inverse of x is equal to, put cos inverse of x as theta. Then x will be is equal to cos theta. We know cos 3 theta is equal to, here cos 3 theta is equal to 4 cos cube theta minus 3 cos theta, that is equal to 4x cube minus 3x. Therefore, 3 theta taking cos inverse with a 3 theta is equal to cos inverse of 4x cube minus 3x. That is the right hand side here. Therefore, 3 cos inverse of x, 3 cos inverse, that is theta is equal to cos inverse of x. 3 cos inverse of x is equal to cos inverse of 4x cube minus 3x. That is the required answer. Question number 4. Prove that 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7 is equal to tan inverse of 31 by 70. So put left hand side. The given left hand side is 2 into tan inverse of 1 by 2 plus tan inverse of 1 by 7. This is given. But we know from our knowledge of inverse tangent function, 2 tan inverse of theta is equal to tan inverse of 2x by 1 minus x square. Therefore, we can write this left hand side 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7 as tan inverse of 2x, 2 into half, that is 1 by 2, divided by 1 minus x square. 1 minus x square is 1 by 4. Therefore, that is in this equation we are substituting x as x equal to 1 by 2. Therefore, 2x is 2 into 1 by 2 into 1 minus x square. X square is 1 by 4 plus tan inverse of 1 by 7 as it is we are retaining here in this line. Therefore, tan inverse of, we can write it as 2 gets cancelled, 1 divided by 1 minus 1 4 is 3 by 4 and tan inverse 7 as it is. That it becomes tan inverse of this previous line equation, tan inverse of 4 by 3 plus tan inverse of 1 by 7. So therefore, this we can write and simplify as, we know from the inverse function tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 plus xy. Therefore, the equation can be written as tan inverse of 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. Therefore, tan inverse, simplifying, that becomes 31 by 7, 21, taking LCM as 21, we get 28 plus 3, 31 in the numerator divided by 1 minus 4 by 21. Further, we can simplify as, if we simplify, it is 17. The numerator is 21 by 31 by 21. Denominator is 31 by 17. So therefore, I will repeat this. Tan inverse of numerator is 31 by 7 and denominator after simplifying becomes 17 by 21. 21 in the denominator in the upper value as well as in the denominator in the lower, this one 21 gets cancelled and it is simplifies to 31 divided by 70. That is the answer and that is the right hand side. You see, right hand side here is tan inverse of 31 by 70 and we have answered it. Question number 2. Question number 5 of 2 marks, we will continue. Therefore, find the value of tan half into sine inverse of 2x by 1 plus x square plus cos inverse of 1 minus y square divided by 1 plus y square for all values mod x, for mod x less than 1 and y greater than 0 mod xy is less than y. So there are three conditions. One is mod x is less than 1. Second condition is y is greater than 0. And third is mod xy is less than 1. These are the three conditions. And we have to find the value of tan inverse. Tan half of within bracket sine inverse 2x by 1 plus x square plus cos inverse of 1 minus y square divided by 1 plus y square. Put x is equal to tan theta. Here in this equation, put x is equal to tan theta and y is equal to tan phi. Then the given equation becomes tan of half sine inverse of 2x divided by 1 plus x square plus half of cos inverse of 1 minus y square plus 1 by 1 plus half square becomes tan of half into sine inverse of 2 tan theta divided by 1 plus tan squared theta plus half into cos inverse of 1 minus tan squared theta divided by 1 minus tan squared phi divided by 1 plus tan squared phi. Therefore, this simplifying, this value becomes sine 2 theta. We know 2 tan theta divided by 1 plus tan squared theta is equal to 2 theta and 1 minus tan squared phi divided by 1 plus tan squared phi becomes cos 2 phi. Therefore, this becomes tan of sine inverse of sine 2 theta is 2 theta. Therefore, half into 2 theta plus half of cos inverse of cos 2 phi is 2 phi. Further simplifying, 2 gets cancelled. This is theta plus phi. Here also 2 gets cancelled. Theta plus phi. Therefore, this further expanding tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. Therefore, tan of theta plus phi becomes tan theta plus tan phi divided by 1 minus tan theta tan phi. That is equal to tan theta we have substituted as x and y we have substituted as tan phi. Therefore, tan theta is x, tan phi is y divided by 1 minus x into y. That is the value, final value for the given equation. Next question. Solve 2 tan inverse of cos x is equal to tan inverse of 2 cosecant x. Therefore, the left hand side we have the given equation 2 tan inverse of cos x equals the tan inverse of 2 cosecant x. We have to solve. We have to find the value. So 2 tan inverse cos x can be written as, we know this function tan inverse of cos is, tan inverse can be written as 2x divided by 1 minus x square. Therefore, the given equation becomes tan inverse of 2 cos x divided by 1 minus cos x square, and right hand side as it is we are retaining. Therefore, 2 cos x divided by 1 minus cos square x, that is equal to 2 cosec x. Therefore, that is equal to 2 cos x divided by sin squared x. That is equal to, right, cosecant x is 1 by sin x. We know cosecant x is equal to 1 by sin x. Therefore, 2 cos x divided by sin x. 2 cos x divided by sin x is equal to this sin x gets cancelled with 1 sin x. So here sin x remains. 2 cos x by sin x is equal to this 2 also gets cancelled and 1 remains. Therefore cos x by sin x is tan x. That is equal to 1. That is right hand side is 1. Therefore tan inverse, if we take tan of 45 degrees is pi by 4. Therefore, x will be equal to pi by 4. Here, in this problem, we have used 4 different relations. These relations are 2 tan inverse x is equal to 2x by x square. We have to first used it here. And the next is sin squared x plus cos squared x is equal to 1. So, that you have used it in the denominator. That is, you have substituted as sin squared x. Therefore, cosecant x. Therefore, 1 over cosecant x is equal to this cosecant x. We have put it as sin x. And then the left side is after substituting tan x. So, tan 45 is equal to tan pi by 4. Therefore, x is equal to pi by 4. Next question. Solve tan inverse of 1 minus x divided by 1 plus x is equal to half tan inverse of x. X for all x greater than 0. Put x is equal to tan theta. So the given equation becomes tan inverse of 1 minus tan x. Here tan x and 1 plus tan x, that is equal to half of right hand side tan inverse of tan theta. Therefore, this becomes tan of 1 is pi by 4. Tan pi by 4 is 1. So, put 1 is equal to substitute 1 as tan pi by 4. Tan pi by 4 minus tan theta divided by 1 plus tan of pi by 4 into tan theta. That is equal to tan theta by 2. Therefore, tan inverse of tan pi by 4 minus theta. That is the formula for tan A minus tan B divided by 1 plus tan A tan B is equal to tan of A minus B, where A is pi by 4 and B is theta. Therefore, tan inverse of tan becomes pi by 4 minus theta. That is equal to theta by 2. Therefore, pi by 4 minus theta. So when this theta goes to right side, 1.5 theta, that is, that right hand side is 3 theta by 2. That we are written here. The right hand theta we are segregating. 3 theta by 2 equals pi by 4. Therefore, theta is equal to 2 gets cancelled 2, the pi by 6. This is the answer. Therefore, x is equal to tan theta is equal to tan of, so theta we are substituting here as tan theta. X is equal to tan theta, that is equal to tan of pi by 6, that is equal to 1 by root 2. You have to remember all the values of tan, cos and sine. In the end of this video, we have given and we have revised and recollected the values of all trigonometric functions. Please go through it meticulously. Next question. Question number 8. Write the function in simplest form tan inverse of under root 1 minus x square minus 1 divided by x, where x is not equal to 0. So the given relation is tan inverse under root 1 plus x square minus 1 divided by x. So in this equation, put x is equal to tan theta. So it will be theta will be equal to tan inverse x. So if we put x is equal to tan theta, then theta will be equal to tan inverse of x. Therefore, tan inverse, the given equation, becomes tan inverse of 1 plus tan squared minus 1 divided by tan theta, because we have substituted the value of x as tan theta. Therefore, x squared here becomes tan squared theta minus 1 and tan theta as it is. Therefore, from this relation, we know, simplifying, 1 plus tan squared theta whole under root is secant theta. That is under root 1 plus tan squared theta. From our trigonometry, knowledge of trigonometry, it is secant theta minus 1 divided by tan theta. Therefore, secant theta is 1 over cos theta minus 1 and tan theta is sin theta by cos theta. Therefore, this relation is simplifying, it becomes 1 minus cos theta divided by sin theta. The denominator, the LCM, this cos theta gets cancelled with the LCM of the numerator. Therefore, tan inverse is this relation. We can write it as 2 sin in terms of half angles. That is 1 minus cos theta by sin theta is 2 sin 2 theta by 2 divided by 2 into sin theta by 2 cos theta by 2. Therefore, this is sin 2 theta by 2 and sin theta by 2 gets cancelled. 2 also sin theta and 2 gets cancelled. It remains sin squared theta. 1 sin squared theta is equal to, it gets cancelled and sin theta remains. Sin theta by 2 and cos theta by 2, that becomes a tan theta by 2. Therefore, the relation is, the answer is theta by 2. Therefore, tan inverse of y under root 1 minus x square minus 1 divided by x is equal to theta by 2. Therefore, that is half of theta is tan inverse x. We have substituted theta as tan inverse x. Theta is equal to tan inverse x. Next question, 2 marks question. We will continue. You know, in this year, there will be 2 questions of 2 marks each. So, more number of problems will be solved. So, question number 9. Find the value of tan inverse of x by y minus tan inverse of x minus y by x plus y. Therefore, we are writing the given equation here. So this we will simplify. Therefore, it is tan A minus tan B. It can be written as tan A minus tan B is equal to tan inverse of A minus B divided by 1 plus AB. This we have to remember. Tan inverse of A minus tan inverse of B is equal to tan inverse of A minus B divided by 1 plus AB. So here we are writing A is x by y and B is x minus y divided by x plus y. Therefore, it is 1 plus x by y into x minus y divided by x plus y. Therefore, multiplying both numerator and denominator by y into x plus y, we get, you multiply the whole numerator into y into x plus y, we get x into x plus y minus y into x minus y divided by y into x plus y plus x into x minus y. Therefore, it becomes tan inverse of x square, x into x square plus xy minus xy plus y square, the numerator. And denominator y into x is xy, y into y is y square, plus x into x is x square minus xy. Therefore, this simplifying xy gets cancelled. The numerator is x square plus y square, and the denominator also xy gets cancelled. Denominator is also x square plus y square. Therefore, because numerator and denominator are same, they get cancelled, and the value is tan inverse of 1. Therefore, that becomes tan inverse of tan pi by 4. Because 1 we can substitute, we know tan pi by 4 is 1. Therefore, 1 we are substituting as tan pi by 4. Therefore, that becomes tan inverse of tan becomes whatever is there in the angle pi by 4. That is theta is equal to pi by 4. Next question. Solve tan inverse of 2x plus tan inverse of 3x is equal to pi by 4. Therefore, the given equation is written as it is, and we are substituting the formula tan A plus tan inverse of A plus tan inverse of B. So that is tan inverse of A plus B divided by 1 minus AB. That is equal to right hand side as it is pi by 4. Therefore, it is 5x minus 6x square. The numerator is 2x into 3x is 6x square. That is equal to pi by 4. Therefore, we take tan again. Therefore, tan of tan inverse 5x by 1 minus 6 square is 5x by 1 minus 6 square equals tan of pi by 4. That is the right hand side. But the tan of pi by 4, we know the value is 1. Therefore, 5x minus 1 minus 6x square equal to 1. Therefore, simplifying, we get 5x is equal to, here cross multiply 1 into 1 minus 6 square. Therefore, 5x is equal to 1 minus 6x square. So, rearranging the quadratic equation, this is a quadratic equation, 6x square plus 5x plus 1 equals 0. Here 6x square minus 1, this should be minus 1. Therefore, the values are 6x minus 1 into x plus 1. Therefore, 6x equal to 1 or x is equal to 1 by 6. That is, x equal to 1 by 6 is the only solution, because x equal to minus 1, the left hand side becomes negative. Now, we will solve 3 marks question. There will be one 3 marks question in your board examination. Therefore, we will solve this. The given question is, problem is, if tan inverse of x minus 1 divided by x plus 2 plus tan of x plus 1 divided by x plus 2 is equal to 4, find the value of x. So, given equation is written as it is. So, in this equation, we have to write tan inverse of x plus y, tan inverse of y is equal to tan inverse of x plus y divided by 1 plus r in terms of AB. Tan inverse of A plus tan inverse of B is equal to tan inverse of A plus B divided by 1 plus AB. This you have to remember. So here A is equal to x minus 1 divided by 2. and b is equal to x plus 1 divided by x plus 2. So you put the value in this equation. Therefore, it is a is x minus 1 divided by x plus 2 plus b is x plus 1 divided by x plus 2 divided by 1 minus 1 minus a x minus 1 divided by x minus 2 into x plus 1 divided by x plus 2 and right hand side as it is. So the next step is to simplify by taking LCM, for both numerator and denominator. So it's by substituting we get x plus 2 into x plus 1 into x minus 2 into x plus 1 divided by x square minus 4 minus of x square minus 1. So simplifying we get 2x square minus 4 divided by minus 3 is equal to 1. Tan pi by 4 we are substituting we are putting the value of tan pi by 4 as 1. Therefore, the left hand side is 2x square minus 4 divided by minus 3 is equal to 1. Therefore, 2x square minus 4 is equal to minus 3 or 2x square is equal to 1 or x square is equal to half. That is, the answer is x is equal to plus or minus 1 by root 2. X square is half, x is square root of half. That is plus or minus 1 by root 2. Now we will take up the next question. Question number 2. Show that sine inverse of 3 by 5 minus sine inverse of 8 by 17 equal to cos inverse of 84 by 85. This is the question. Answer. Let in the given equation put sine inverse of 3 by 5 as x and sine of minus 1 sine inverse of 8 by 17 equals y. I will read once again. Sine inverse of 3 by 5 as x and sine inverse of 8 by 17 as y in the given equation. Therefore, sine x will be 3 by 5 and sine y will be 8 by 17. This is given on the right hand side. Therefore, we also know cos x is equal to square root of 1 minus x square. That is, the original formula is sin squared x plus cos squared x is equal to 1. In that formula, we are writing again. Therefore, this becomes square root of 1 minus x square is 1 minus 3 by 5 whole square. That 3 square is 9 divided by 5. 5 square is 25. This becomes 4 by 5. Therefore, cos x will be equal to 4 by 5. Now, similarly, we will take cos y. Cos y is equal to, it is given, we know that the relationship cos y is equal to square root of 1 minus sine squared y from the basic relations in trigonometry. Therefore, sin y, we know that it is 8 by 17. Please look on the right hand side. Sin y is 8 by 17. Therefore, it is cos y is square root of 1 minus 8 square by 17 square. Because here sin square is there. Sin squared y is there. So, we are taking 8 square by 17 square. Therefore, simplifying, take LCM, 17 square as LCM. This will be 17 square minus 8 square divided by 17 square. Therefore, solving 17 square minus 8 square and 17 square, we get this numerator is 225 divided by 17 square and take the root. It is cos y is equal to 15 by 17. Now, let us take another trigonometric relations cos of x minus y. We know from trigonometric knowledge cos x minus y is cos x cos y plus sin x sin y. Therefore, that becomes 4 by 5 into 15 by 17 plus 3 by 5 into 8 by 17. That is, the values are given here. 4 by 5 cos x, cos y is 15 by 17 plus sine x 3 by 5 into 8 by 17. So that becomes simplifying. 5 into 17 is the LCM. We get 4 into 15 is 60 plus 8 into 3 is 24 divided by 85. Therefore, the value of this value becomes cos of x minus y 84 by 85. Therefore, if you take, now to find the value of x minus y, we have to take cos inverse of x minus y. That is, x minus y will be equal to cos inverse of 84 by 85. Therefore, x is sine inverse of 3 by 5. We know, you see, x is sine inverse of 3 by 5 and y is sine inverse of 8 by 17. Therefore, substituting the value of x and y in the left hand side, we get right hand side is cos inverse of 84 by 85. So, we have solved all the problems. Next slide. Next slide is to recalculate the trigonometric ratios and formulae which we have studied in class 10 and class 11. These relationships are given here. Please go through. This is also you must have written down in your notes of previous classes. These are given it here. The basic sine function, cos function, tan, cosecant, secant and cotangent and the basic relations are also given and their interrelation is also given. Here also some formulae which we have used in solving these problems are given here. Please remember them and note down, and while solving, please recapitulate and solve your given equations. Here in this table, we have given the trigonometric ratios of selected angle. This is also revision of class 10 and class 11. These relations are given. Sine of 0, sine 0 is 0, sine 30 is half, and sine 45 is 1 by root 2, and sine 60 is root 3 by 2, and sine 90 is 1. Similarly, the relations and the values of other angles, theta, varying theta, different values of theta as 0, theta equals 30, theta equals 45, theta equals 60 and theta equals 90 are given, and the corresponding trigonometric ratios are also given. Please study, note down and use it while solving your problem.